So example number 25, evaluate the integral. And you've been told to integrate 4x cos 4x dx, isn't it? So if you look at this problem, it is a product of two functions, isn't it? The polynomial and the trigonometric. So you can let the polynomial to be the old 4x, or you can factorize 4 outside the bracket. You see, when you put 4 constant outside the bracket, it means 4 will affect everything inside, isn't it? So there's no need of taking 4 outside to avoid coming back later to multiply everything by 4, isn't it? So to avoid coming back later to multiply everything by 4, just let 4x, the whole of it, to be u, isn't it? To be polynomial function. So that it is a coefficient of the polynomial function. Are you getting that? Are we together? Then the whole of this cos 4x dx to be dv, isn't it? Are we together?
Yeah.
So that is integration by parts when you have a product of two functions, isn't it? So u is 4x. So if you differentiate u with respect to x, you get du over dx is equals to 4. You take dx the other side, you get du is equals to 4d, isn't it? Du is 4 dx. Then you've said dv is cos 4x dx. The whole of this is dv, isn't it? But you don't want dv, you want v. So how do you get v from d? You introduce integral, isn't it? So when you introduce the integral on both sides of the equation, if you integrate dv, you remain with v, isn't it? So v is equals to, if you integrate cos, positive sign, isn't it? Positive. So if you integrate cos, we get sine 4x, then we divide by the constant of the inner function. The derivative of the inner function must be a constant. 4x, if you differentiate, you get 4. You divide it, isn't it? Are we together? So you've now done everything. So what should be your answer? You know that when you are integrating u dv, you are supposed to get uv minus vd. You are supposed to get uv minus integral of vdu, isn't it? Are we together? When you integrate u dv, you are supposed to get uv minus integral of vdu. So can you now start substituting? This one is equals to u times v. U is 4x times v sine 4x divided by 4. See, 4x times this, you remain with x sine 4x. 4 will cancel with 4, isn't it? So this times this, you remain with x sine 4x. So you multiply uv, isn't it? Then it is minus the integral of v du. V times du, v is this, du is this, isn't it? Are we together? This times this, see this 4 in the numerator will cancel with this 4 in the denominator, isn't it? So you remain with sine 4x dx. You remain with sine 4x dx. So what are we now integrating? That. Meaning you have to do it until you no longer have integral on the right hand side of the equation, isn't it? Meaning we are now integrating sine 4x. So this is no longer a product of two functions, meaning it is just a sine function. We integrate a sine function on its own, isn't it? Are we together? Good. So what do we have? This one is equals to x sine 4x minus, then inside this bracket, if we integrate sine, you get negative cos, isn't it? Are we together? You get negative cos. So negative cos 4x, then we divide by that constant of inner function. The derivative of the inner function must be a constant. If you differentiate 4x, you must get a constant. It's when that holds, isn't it? Good. So after that, at the end, there's no any more integration. There's no more integral. So we add our arbitrary integration constant because of indefinite integration, isn't it? So what do we have if we simplify this? X sine 4x negative into negative, positive, then 1 over 4 cos 4x plus c. Are we together? Good. So don't always factorize this constant. Just leave it inside to remain as a coefficient of that polynomial, okay? So that you are not going to work with a lot of brackets when you are simplifying further. So that is how to handle that given problem.